Welcome back to the course. In the last part, we were creating the Bezier curve get point function. Well, actually for the quadratic Bezier curve. Also, I explained to you how we are going to go through that. And now we are start coding from the very left point. Then we go and loop through all the past points now and add the needed parameters to our passholder object. So at first, we want to create a Bezier curve based on points. We can actually define how many steps we want to have in between that. So how many steps do we have as a possibility? When we open up our pass script over here, we want to add a new integer. This is going to be a public integer since I want to have the possibility to actually set this one by hand whenever I need a higher or a lower density inside that curve. And since speaking of density, I'm gonna call this line density. And we basically don't need to set this thing up to anything, but maybe we want to set at least one. So meaning at least one point is on our Bezier curve. Also, I want to create a slider for that. It is going to be in square brackets, we can say range, and we want to set this somehow between 1 and a maximum of 20. How does it look? Let's pretty quickly look into it. Whenever we are going back to it, to Unity in here, we're should have a line density slider. So currently set to be 1. We can put in a number, or we can arrange that so that we can slide this one up and down to our needs. Do yourself a favor and do not overdo it. 20 is more than enough, depending on how long the distances are between those curves, of course. But in the end, we don't need more than 20. I believe not even more than 10. What we also want to have is a new list, which is taking care of all the points on the Bezier curve. So when you once again remember these purple points over here, these are going to be the points for our Bezier curve, or which are forming our Bezier curve between P0 and P2. So how do we do that? At first, we create a new list of type vector3 in this case. And I'm gonna put the line density parameter on top because I want to make sure that we don't have any weird stuff running in the inspector. Meanwhile, we are adding to the line density because at the moment we start with a public list of that. Later on, we can just make it private. So this list is in this case of type vector3, and it is our Bezier obj list, and we're gonna set this one already to be a list of type vector3, open close parentheses, and close the line with a semicolon as usual. So meaning we can instantly put in data into it without initiating this one in start, which is actually not needed. Okay, so based on that line density, we now want to fill in points calculated by our getPoint function we have created in the last video. And we want to do all of that inside the onDrawGizmo function after we are done with this for loop over here, where we are painting the green gizmos and the green lines, basically. At first, I'm gonna make a small command in here, so that means everything after that is going to be about the curved path or the Bezier path. Once again, how you comment things out is up to you. Make notes as much as you need it so you have no problems with some follow-ups later on. Most important one is I put another one here. I want to check for an overload. I'm gonna explain this a bit later on. And after that, the first thing, as we already have done here with the pass obj list, we want to clear the Bezier obj list. So we say Bezier obj list dot clear, because once again the onDrawGizmo function is always running inside the inspector time, so meaning we always have to clear it and refill it automatically, so we don't need to take care of anything else. So this is the most important one over here. Then what we want to do, we want to set our line start for the first loop ever. Meaning we want to take this first point over here, the first pass point, which has like no gizmo, and we want to take this as the first point as an indicator where do we want to start. So we create a new vector3 and we catch that into that particular point into it. So, and since we know where it is, we can say we name it line start. It's going to be equal to, we take this from the pass obj list, from the first element, in this case element 0, and we take the position of it. Don't forget the end the line with a semicolon. So now we store the line start based on the first position in the path, no matter where it is. So what we now want to do is we want to loop through the complete path obj's list, check for an overflow or underflow, and then we're gonna create all the points based on the vector3 getPoint function over here and fill it inside the Bezier obj list. So let's create a for loop. So we type in for and double tap. Last time I didn't explain this pretty much. You press tab twice after you were typing for, and it should automatically fill up the data. So I is going to stay, the int I is going to stay the same. Since we have this other for loop here enclosed already, we can still use, or once again use I as an indicator to loop through, or our index we are taking for this. So what we are looping through is in the second parameter here. Once again, I keep this I. This one here is going to be our path obj list.count. So the amount of points we have in our list, we want to loop through them. Now the fun part comes. Gonna go back to Inkscape pretty quick. We want to, since P1 is going to become declared as a handle and not directly as a point, we want to overhop this every 1 point. Like every second point, in this case, we want to hop over this because we are just using this as a handle. What do we do is I at this point is going to be 0, I at this point is going to be 2, meaning usually we say I++, and we would run from this point to this point. But since we want to not take this in consideration, we overhop it by saying I plus equal 2. So meaning we hop over. We add to I when it is at 0, we add 2 to it, and we overhop this one and go to this point. Otherwise, we don't get a curve. Otherwise, it would just be still a straight line. Since, once again, we already did this over here, as you probably remember. So basically, it's the same what we start with, but we overhop this every second point in the path obj's list. Now we create a nested for loop. So we type in for again and press tab twice again. And this indicator here should be a J indicator. So this J, this is J, and this is J. Or you can also take any other letter except the I letter. So, and what you want to do is max in here is going to be smaller or equal to our line density parameter. Like this. So if J is smaller or equal the line density parameter. Somehow it doesn't let me do anything here. So if J is smaller or equal line density, we're gonna go and hop forwards and go into the next point. So now line density becomes the number, but on this point, let me go back to this, the number we want to take here inside this loop. So when we say we only have 1, we go from here to here. It's a straight line in between point 0 and point 2. If we have a 2 inside, we're going to have like a center point over here, and we have like a little triangle. The more dense this part is going to be, the more numbers or the more line density we have, let's say 10 points, then we have like 10 small points on this line curve, and we actually can shape this particular curve. The more points we have, the smoother the curve is going to be. And we're gonna need these points to navigate our ships around based on these points. So that's important that we're going to use those. Okay, so what we now want to do is we want to calculate the next point after line start. The next point in this case is going to be of type vector3 again. And this is going to be called line end. And line end is going to make sure that it is using our getPoint function. So we say getPoint, and now we pass in all important parameters here. What do is we say at first, the first point, though, so P0 is inside our path obj's list. Then we take the index parameter of I, so in square brackets I dot position. Then we have a next point. This is going to be P1 in this case. It's basically the same. I copy that. Make sure that you always have position with it. And in here, in the second one, it's going to be I plus 1. So the next point from the current point we're looping through. Then we have another comma over here and set this I plus 2, because this is going to be the second point in the list. And then we have the time parameter t. And t is now the interesting point, because we want to take the line density in consideration. So the higher, once again, it is, the further or the more often we're going to loop through that get point function and get the point function based on the percentage the current point we are looping through on the curve, based on the line density. So what we say is j, and now we divide j by line density. So j, once again, is the current point or the current density we are at. And since we want to have a float number between 0 and 1, we need to typecast a line density to a float. Otherwise, there would be just an outcome of 0. So we say in open close parentheses, before line density, we type in float. Oh, like so. So meaning we now take j, and we divide j by the line density to get a number between 0 and 1. So if j is equal to line density, it is 1. If it is smaller, like if j is 5 and we have a line density of 10, then we are at 0.5. That's what this mathematic calculation is going to be for. Don't forget to enter line with a semicolon. And when we are going back to Unity right now, we should get a lot of errors. But that's okay. And what we're going to do is, in the next part, we are actually fulfilling the rest of this. As you can see, there are some argument out of range exceptions, but please continue within the next video. Otherwise, this video would just be too long.